school here at the end of the day goes back, takes this home, and does this at their own school for all of the learners. I think that would be great, right? Awesome. Awesome. So how did we get here? Well, my name is Zandra. I'm from the Africa Millimeter Telescope Project, the AMT. We're a project here in Namibia where we are building a telescope right here in Namibia to take images of black holes. And we don't just want to do that, but we also have a heart of inspiring the next generation. Some of you...
We cannot hear anything on our side here, folks.
Who of you have seen the mobile material? Okay, for the other schools, you're welcome to invite us, and then we'll come to your school and do outreach, but that's something separate. For now, what we're doing is we're not doing a planetarium event, we're actually going to have a discussion with an astronaut in space. So that's something very cool. I hope it's inspiring. I hope that's why you're here and why you are excited. And that's the type of activities we want to do from the Africa Millimeter Telescope side, the AMT side, but not just from that side, also from the NSS side, the Namibian Scientific Society. We've been working together with these types of outreach activities over the years. With the Namibian Scientific Society obviously being a custodian of all spheres of science, but also having an astro working group. So some of you might think the astronauts and the astronomers are only overseas. Some of them are actually here local. One of them will be speaking to you later. Not an astronaut, but an astronomer. Namibia's first PhD graduate from UNAM. So we're excited for that as well, to give you a motivational talk. So that's the AMT and the NSS working together. And then every year at Space Week and a few other activities, we also love working with World Space Week together with the NCRS team that are the custodians of World Space Week. You might not know there's a World Space Week, but you are actually part of it this year. So every year between the 4th and the 10th of October, there's World Space Week. And we try and make it every year a bit better. I think this is the best year yet. Or would you agree with me? Well, we'll see a bit later, because you guys are going to do something that has never been done. So that's sort of the background of all the more like residents all working together to make this event a possibility just for you guys. Straight into the program, we have for one main thing to speak with astronauts in space. And we have 11 schools. We have one learner. And these are learners that have prepared questions that they are going to ask the astronaut directly in space while the International Space Station travels overhead, and have an opportunity for the astronaut to actually answer that live. And all of you will be a witness of that, being able to hear that. Now, what's very important? Listening. Listening very silently. Because what's going to happen is this microphone is transmitting something into a laptop. That laptop is transmitting it to Belgium. Belgium is in transferring it into a radio signal, sending it upwards into the International Space Station as they move over, and we have a very small window of opportunity. So let's say somebody's asking the question, and you guys get too excited and it interferes with the sound, then unfortunately the astronaut will have to say, please repeat the question. Then we lose valuable seconds. So can we have an agreement that we all work together? Awesome, because we're doing this as a team. Remember, it's an experiment. It's an experiment. We want to see if it works. But in order to make it work, we all need to work together. And for that, we are very excited that you are here and so excited with us. And thank you for your participation in advance. So what we're going to do in the program is actually go into the most important part of the program is a practice session where the learners are going to practice their questions and the flow of it before we actually start with the pre-program presentation. Around 18 minutes past 12 or 17 minutes past 12, our colleagues from NASA, maybe they can say hi in a second or two. They are actually going to take over the program and then regulate us from there. But before we do that, we're going to do a practice session, and then we're going to have a few motivational and inspirational talks for you guys. Are you guys excited? Awesome. So let's dive straight into a practice session. So maybe I can ask the learners to come up. Ryan, I don't know, do Frank and Jan just want to say hi to the audience? Yes, we can hear you loud and clear.
We didn't hear any audio till just a couple minutes ago, so I think we're getting established here.
Okay. Yeah.
All right. Sandra, are we ready for the student practice?
Do you want me to practice my introduction as well, or can we just go to the
Absolutely, absolutely.
So we are all practicing. So are you going to give me a cue, Jan, from your side?
Okay, though you're waiting for me, I just testing my transmission with your audio, so that sounds good.
Okay, so he needs a cue. Jan, he needs a cue as to when the space station is overhead and the astronaut is ready.
Okay, so when the communication is established, I ask astronaut Mike Fink if he is ready, and if so, I pass the communication to the school with the words, Andre, go ahead. So that's a sign that you can go with the first introduction and question. That okay?
A warm welcome here from the Windhoek Afrikaans Private School. We have a bunch of learners that are ready and eager to ask you a question. We're going to go into the first one with Mikeson.
Hi, this is Mikeson. Would you recommend your current occupation to another individual? Over.
Yeah, that's a very good question. Over.
Hi, this is Joseph. What form of communication does one use in space? Is the internet in space? Over.
Yeah, that's okay. Over.
Light takes millions of years to reach from distant galaxies. With some of those galaxies already before by the time we see them. Over.
Yeah, that's okay. Over. May I ask you? I have a little bit, I think, an echo or something like that. Can you confirm that, Frank?
Yeah, I'm hearing it too. So I'm not sure if Reinhardt can fix that or not, but we are hearing some echo. And I'll say, from if the last student is okay with you, Jan, it seems a little quiet for me. But you're most important because you're where their voice goes into the radio to the International Space Station.
Yeah, okay. But I can fix that, so no problem. So, yeah, we were in the third question. We continue. I understand it. Over.
Oh.
I'm not hearing anything.
Yeah, me either.
Frank, can you hear us now?
You're kind of breaking up a little bit, Sandre.
Testing, is that better, Frank?
I'll have to ask Jan how it's sounding.
Yeah, I understand it, but say again, please.
Yeah, we testing
something.
Sound is better from our side. Can you hear me clearly?
Yeah, I understand what you say, but I still have a little, feedback from something, a loudspeaker or something like that. So, but that's, try to fix it. I propose to continue asking questions.
Let me just quickly ask a question here to our tech team. Reinhard, do you think it might be that we're standing too in front of the speakers?
We're having a bit of internet latency issues, but as we continue over the next 10 minutes, we will fix it as much as we can.
And the sound feedback that they are talking about is anything, have you fixed it already?
We're busy with that as well.
Okay, cool. So we're just going to continue, Jan. I'm going to give over to question 4, and then we continue with the practice session if that's fine with you.
Yeah, go. Over.
Hi, my name is Suing. If you could take one thing from Earth into space that makes you feel alive, what would it be? Over.
Okay, that's fine. Over.
Hi, my name is Emily. How do you overcome the challenge of missing home and family as you travel in space? Over.
Okay, that's fine. Over.
Hi, my name is Aaron. What life support systems help astronauts survive in space? Over.
Okay, that's fine. Over.
Hi, my name is Pepe. If black holes and white holes exist, could there also be something like a blue hole? Over.
Okay, that's fine. Over.
My name is David. What impacts does the launch, landing, and stay in the space station have on the human body? Over.
Okay, that's fine. Over.
Hi, my name is Prince Ahil. How does a massive star dying create a black hole so powerful that time slows down and bends its light? Why do we only ever see its effects and not the black hole itself? Over.
Okay, that's fine. Over.
Hi, my name is Akasio. Why is dehydrated food commonly used in space missions, and what types of food and beverages do you consume while aboard the spacecraft? Over.
Okay, that's fine. Over.
What would happen if something falls into a black hole?
I don't know. Over.
Jan and Frank, we just completed the first round of questions. Just also, by the way, we have all 11 learners here, so it's a full house. Do you want us to go for the second round as well? Over?
Yes, we do.
Okay,
We want to go through the whole thing.
let's go for it. Mikeson?
This is Mikeson. How is life in space? Over.
Mikeson is very good. Over.
This is Joseph. How does one know where to land when going to the moon? What gives you direction? Over.
Don't forget. Over.
Why do most galaxies seem to have supermassive black holes at their centers, and what roles do these black holes play in galaxy formation? Over.
Okay, that's fine. Over.
What is the most surprising thing you had to learn on Earth that actually helps you the most in space? Over.
Okay, that's fine. Over.
What role will robots and artificial intelligence play in future space missions? Over.
Okay, Emily, that's fine. Over.
What interesting space science experiments are you working on aboard the International Space Station? Over.
Okay, Aaron, that's fine. Over.
What would happen if Saturn's moon Titan were to come near or collide with Earth? Over.
Okay, Katala, that's fine. Over.
David, how are space vehicles able to dock to the space station, and do they all return to Earth? Over.
That's good. Over.
Akasio, how do you keep time in space, and how does it differ from Earth's time zones and calendar? Over.
Yeah, that's okay. Over.
Can stars really live and die like people say? Over.
Yeah, okay, that's fine. Over.
Okay, that was great.
So
Congratulations. Go ahead.
yeah, the audio, the strength of the audio is fine, but it's still a little bit, yeah, echo around or something like that from feedback. But we try like it is.
Okay. All right. So, Sandre and Reinhardt, I'm not sure how it sounds in the live stream, but the youth, all of the students did a wonderful job.
From our side also, the audio sounded perfect and everybody worked well together. So we are very satisfied with the practice session. If you guys are fine, then we can go on with our pre-program.
That would be fine.
And also for our living student. I think they did a great job, but you guys also did a great job. Thank you for working with us. And maybe out of interest sake, how did these questions come about? Well, all of them prepared a bunch of questions, and then we actually shared them with Frank, that's sitting all the way in America, who shared them with NASA, and they went through a few committees to regulate the questions, actually, to make sure that they are on topic and that they are appropriate and that they are actually suitable for the event. Then they sent them upward into space. So our astronaut friend in space already has the questions. He's preparing answers because some of these questions are difficult questions. Well done on preparing it. So he's going to answer them as best as he can in the given time that we have. And this is why we're practicing it also together. So thank you again for that. And with that, we're going to go over to an awesome item on our pre-program that we have. We have a bit of a pre-program that's going to lead up until 18 minutes past 12. And we'll see how far we get. If we don't finish the pre-program, we'll do some of it afterwards. Is that good? Awesome, because we have a lot of people lined up that are very excited to speak to you. But our first speaker today is Prof. Anisha Peters from the NCRST.
Yeah, I don't know if you read
She's here to give you
Reinhardt's text message. The audio is going to go on and off while he tries to improve the audio. Okay.
Yeah.
Good morning. Goedemorgen. Guten Tag. Okay, so this morning I was asked to speak to you, but let me just recognize first of all Mr. Brutus Esbach and Ms. Wayne Terber, the school principals at the Windhoek Afrikaans Private School. Then I'd like to recognize also all of our partners, the Scientific Society, the African Millimeter Telescope, and then of course I am from the National Commission on Research, Science and Technology, and I am what they call the Chief Executive Officer. Think of me as the school principal this morning. So it's really my pleasure to join you here for this exciting event. And this is really exciting to have this opportunity. I would have never thought in my lifetime that in Namibia we would have actually been able to make this direct contact. Now, this activity is part of World Space Week that happens every year around this time, and it happens around the world. And Namibia has been celebrating this for over a decade. Now, during this week, we teach young people about science and space, encouraging innovation and creativity, supporting research and technology, and inspiring future scientists and engineers. On the stage while you're speaking. So, for this living in space, hence why we have such these questions about what it's like to live in space. Now, we had a Namibian scientist, a foremost scientist at NASA, and his name was the late Dr. Japie van Zyl. Who's heard of him? Okay, some have heard of him. Unfortunately, he passed away, but Dr. Japie van Zyl always came during Space Science Week and he would speak to everybody. And he won some prizes as well. But I remember also that we took one of our old sort of aircraft from many, many years ago. I don't remember what it was called anymore, but I flew in it once. And he said that he wanted to restore it. So I hope that someday one of you will actually pick it up. Now, the National Commission has a number of science promotion programs, like the National Science Fair. And I believe that from Windhoek from VAP, there were also some winners in the science fair this year. And then, of course, from, I believe there are between 8 and 10 schools, that many of your schools have also prizes. But we also have the International and national and regional mathematics Olympiads, where you can participate in the mathematics Olympiad, and it can basically be your ticket to the outside world as well. Because this year we sent 4 learners to Australia, and we got a special commendation. But we also had 3 learners who got scholarships to go and study in the USA. And we got one who won actually a bronze medal at the Pan-African Olympiads. So that could be sort of your ticket out. But besides that, I want to quickly give you something personal about me, because it seems as if me and space, we are now inseparable. So I was born in a small place called Riobel, and I went to Oregon Primary School for 1 year. Then I went to Windhoek Primary School. Then I went to Concordia College. I was there with Frank Fredericks, who's heard of him. Okay. From there onwards, I left Namibia and I went abroad. I lived in Germany, then I lived in the Netherlands, then I came back to Europe. Then I fell in love with Namibia as well as a man in Namibia, and I got married and I had two children and at that time. And then I studied at the Polytechnic of Namibia. I studied computer science. Who wants to study computer science? Okay, once we're done, I know that Prof. Bakker sitting there will probably not be happy, but once we're done, I'm hoping that many more of you will want to study computer science. Anyways, I started studying computer science sort of in the evening, and then once I was done, I was invited by the US Embassy, sort of applied for a Fulbright Science and Technology scholarship in the United States of America, do a PhD in computer science. And off I went with all of my family, but one fun fact, before that event happened, I was teaching at NUST, now it's called NUST, and at the time I was saying, you know what, I'm 37 years old. My time for going to NASA, because I always dreamt about going to design systems for NASA, was basically over. Like, I thought my life was over. And I told my students that this is what you need to pursue, something like that dream one day to get beyond your own borders, beyond your own what you dream, to be able to imagine it, to be able to pursue it, to be able to make it a reality. So lo and behold, I'm invited, okay? We're going to study now computer science, and I go to a place called Iowa State University, where I'm studying in the Virtual Reality Application Center. And who do I encounter first? NASA. NASA projects. Wow, I could pinch myself. Then I encounter building projects, right? Building aircraft. Then I encounter, okay, we're building tractors as well. I worked on some of those programs, building tractors for John Deere. But then I got the exciting opportunity to visit NASA JPL when this was 2011, when they were building the Curiosity Mars rover. And it was so exciting because I could see how they were building it actually on the production floor. And I got to go to Cape Canaveral. Who knows what at Cape Canaveral, what do they do in Florida? Launching. That's where they launch everything from, right? And they launched Curiosity also from there, and I got to watch it. So now this was exciting, right? But I'm still not living my dream. But in the career fields that I discovered while I was studying, I studied something called human-computer interaction. Today you see it as human-centered AI. Today you see it actually the whole AI field, sort of driven by it, robotics, etc., mobile phone, etc., and what you do on mobile phone gestures, etc. 3D modes, that's sort of what we study. That's within my in my domain. So I also found that there were other people studying things such as nano guiders for missiles. There were people who were designing their own planes and flying them. I found that material science was such an amazing field, and it was just amazing. Like there was space, within the space science field, there were just so many careers that were being studied. But back to me now, I'm doing computer science and so on. And when I came back, my relationship with space did not yet end. Because when I got back, I got the opportunity to go visit the space stations, institutions in China. I got to visit them in Italy. I got to visit the Space Research Center actually in the Netherlands. And then I got to NCRST. When I got to NCRST, I was like, oh, no, wait, I was first at UNAM. So I was at NAST, I was teaching at NAST, then I was the Pro-Vice Chancellor at the University of Namibia. At NAST, I was a faculty dean for computing. Then I was the Pro-Vice Chancellor for Research, Science and Technology. Nowhere, that's now confusing. For Research, Innovation and Development at University of Namibia. And the first person I'm meeting, I think it was the next day after I started, was that professor over there, Professor Michael Bacchus. He came and he said to me, to go to the ISS telescopes. And I'm like, I've always been dreaming of going to the ISS telescopes. Even since I was younger, I've always dreamt of it. And so we got everybody together and off we went. It was so amazing. If you haven't been to the ISS telescopes, please take it number and please make sure that you make it to go there, because it is something amazing. It is some of the world's largest telescopes just outside of Windhoek, and it's gamma ray telescopes, and we can explain what it means, all of it. But it is also one of the top 10 observatories in the world, right here in Namibia. Who knew that? Guys. Okay, one knew that. That's why you can go study physics, right? You can do a lot in big data, you can go study AI, so many fields that you can study. And when I got to NCRST, I saw that NCRST has a mandate for space science. So we have the National Space Science Council, and everything space science related actually comes home at NCRST. So we coordinate, promote, and develop research, science, technology, and development. So I'm wondering now, after this
That's awesome. And I think a beautiful thing of that story is that your story is never done. And so don't limit yourselves about what you think is available. There's a lot more available. One thing that we love to tell learners whenever we do outreach is be curious and ask questions. Sometimes we are scared to ask questions, and if we are teachers, we are definitely scared when the learners ask us difficult questions. But don't. These days the access to that information is just a few buttons away, or maybe even a few people away. There are smart people right here in Namibia. You can do field trips to HES sites. You can do field trips to data center sites at NAST. You can see these things. You can see Namibians programming some of the most sophisticated that we can only dream of, and we're doing it all from right here. So I would encourage you, work hard at science, work hard at maths, work hard at the difficult things, give yourself a shot, and at the end of the day, you can become whatever you want. So we're going to go over to our next item on our program. We still have a few minutes left before we give over to the NASA team. We're going to call up Andreas from Minds in Action. Now, Andreas and his colleague Dika, they're sitting here. They have a robot school right here in Namibia. Did you guys know there's a robot school? Some of you say yes. Some of you have it at school. Maybe if you are, that's awesome. If you do not have it at school, you can always go and visit Minds in Action, if you want to make a note of that. But them being knowledgeable about robots and also about tech stuff in the world, and Andreas, I know to also be an astronomy enthusiast because he did 1 or 2 courses in that. He's going to be telling me more about the International Space Station itself. Just a few fun facts about that. And then maybe we'll have space for 1 or 2 questions. We'll see. But we're going to give him time to just tell you a bit more on the space station that we are actually going to speak with a bit later. Are you guys excited? Let's give him a hand of applause as he comes up.
Good morning, everyone. Good morning, everyone. How are you guys doing? I want to repeat the same question. Are you guys excited? We should be excited because you know why? We have an opportunity to speak to someone who is currently living on the International Space Station. And we are the lucky ones in the whole country. Can we clap hands for ourselves? Thank you so much. My name is Andreas Leonard. I'm from Minds in Action. In my role there, I'm a co-founder and I'm also a chief operations officer there at Minds in Action. I am coming from the background of information communication technology. I studied information communication technology in NAST. At Minds in Action, we specialize in STEAM education, which is science, technology, engineering, arts, and mathematics. And we do this by using hands-on training systems. So we expose Namibian learners, primary and secondary learners, to skills in robotics, in electronics, in 3D printing, in science, and we are located in Booster Machine Tools building in Saidroga. Like what Zandre said, if you are interested in learning such skills, do visit our STEM center or our STEAM center. Okay? About the International Space Station. So, as Prof was telling you guys here that Namibia is identified as one of the good regions in the world where space missions and space activities can happen. So, you as young Namibians, bright young Namibians, take up opportunities that are going to come, research and find out what are the careers that are available for you in this space activities, so that when the opportunities are going to come, you are the first one to grab it. Thank you.
Thanks, Andreas. That's awesome. We have time for one question from the audience to Andreas. Does anybody want to ask him a question? Do you see a hand? There's a hand there. Thank you.
When we pose the question. Unfortunately, I don't have that answer right now. Yeah. Seven. Okay, we have an answer here. Apparently, they are seven. 7 astronauts currently in space. Thank you so much.
That will be my video how long does it take the spaceship to send it to space?
It takes many years. It takes a lot of engineering and research, so it takes many years. And the International Space Station, for it to be in space,
And that is what we call perseverance. There's always support, curious minds. The teachers are always there to help. We have the NCRST that actually funded me through my master's. We have the AFT that funded me through my PhD journey. There's always people that are willing to help as long as you have dreams. So there's always people to keep you on the right path of your dreams. So if they can help me, they can help you. If I can do it, you can do it. In closing, I want to leave you with this. You don't have to be the smartest person in the room. It doesn't matter if you come from a rich or poor background. What matters most is your curiosity, your imagination, and just to persevere, just to keep going when you need to get going. Watch The Expanse. It's one of my favorite shows. And when you watch it, start asking yourself, what if? What could be? Well, what? You one or two questions. Maybe you can just tell the audience On what topic did you do your PhD? Just a bit of detail there.
Okay, so I did my PhD on the AMT. So I worked on the Africa Millimeter Telescope, in which I did site testing between two sites. So basically, I looked at the candidate sites for the AMT, and we basically tried to figure out from the two sites which would be the best for the AMT. So the Africa Millimeter Telescope basically observes at a frequency which is very sensitive to water in the atmosphere. So if you have water in the atmosphere, then you basically have a hindrance to your observations. So I basically looked at two sites and tried to figure out which is the best for observations. And in this, I also conducted simulations of black hole to see how the AMT would perform in observations of black holes with other telescopes across the world.
That's interesting stuff, right? Just give me a hand of applause. Obviously, when it comes to space, there's two different things, right? There's space observation, standing on Earth looking into space. This is what astronomers do, right? And then space exploration, that's what NASA does, traveling in space. So both of them have to do with space. It's the same physics. You have to understand the same things. So he's an observer at this stage, and these guys are studying the same. And then today we're going to have the privilege of speaking to somebody that's actually exploring space physically himself. While we are still with Lot here, or Dr. Lot, does anybody have a question for Dr. Lot? There's a question right there. There at the left back, the hand is up. And then we have one as well. We'll just take two questions and then we'll see how much time we have left.
How many light years does it take to travel to the Andromeda galaxy?
So I will that one. So my main study is basically on the black hole. So that's my main area of expertise. 2.5 million light years. So I hope you know what light years are.
Sir, I have a question.
Yes, sure.
If human, if an Einstein about his look, what is the percent of human surviving the gamma rays of a slow star?
So it depends. It's in our sun. So is it a star that is far away? Is it our sun? So if it's our sun, then we are basically kaput. So we are basically finished. But then, so our sun will not explode within the next possibly 4 billion years. So we still have another 4 billion years to go before it explodes. So we are still safe.
So I can hear there's some excitement in the room. I think we have about 5 minutes left before we have to hand over to our colleagues in America. Before we do that, I think the underlying narrative of all of these, even from Prof. Anisha to Andreas to Lot, is that if they can do it, we can do it as well. we just remaining focused, right? One of the questions was, how long does it take to build such a instrument in space? And that was the question there. I think somebody Googled, Andreas said that every mission that they go up, they build something new, and it started in 1998 and they are still constructing, right? So that's a beautiful mission of story of the International Space Station. But even about satellites right here in space, right here in Namibia, did you guys know that the NAS, Namibian University of Science and Technology, are actually building satellites right here with these students? Did you guys know that? Maybe for 2 minutes we can ask Prof. Anisha just to come say something about that. And then you guys also know that you can go study IT, you can go study astrophysics, you can even go study something in space exploration.
She is then. What she does and inspire you to get into careers.
Hi guys, so my name is V. So my name is V. I'm currently Muslim. I'm a student at the University of, okay. I'm a student at the University of Namibia. I'm currently pursuing my undergraduate degree in physics and computing. I have a dream or a mission. I have a mission to become an astrophysicist. So that's the idea. Yeah, that's why I'm here.
NCRST does is that we work that we're funding scholarships for masters and PhD. Oftentimes it's part of a research, what they call a research grant. So we're funding also sort of Namibian researchers in nanotechnologies for disaster risk management, and then also Earth observation for crop monitoring. And we have currently also some research funding that has opened up, and we will do some more of this type of disaster risk management. But that's oftentimes for sort of space science, right? What we want to do. We want to be able to see the fault fire in Etosha. Who read about it? That one, we could have monitored it from space. When we have flooding or imminent flooding, we can monitor it from space. In fact, NASA had a project specifically for Namibia to monitor the flooding that occurs annually so that they can develop early warning systems. But at NUST is a school of space science, and at that school of space science, they're actually building those satellites currently. Then the Ministry of Education actually has a ground satellite receiving station. It is built here. Who knows where the telecom station is? It's up on the mountain. That's actually where the ground receiving base station is. So I think that in Namibia we are doing quite well, and I think that we are opening up those careers to all of you, and along with funding opportunities. So as you are navigating your school career, think about what you want to become, and then consider all of these career choices.
That's awesome. So I think we're now almost on the minute ready to give over to Frank and the team. Reinhard, do you have it there?
I'm Frank Bauer. My amateur radio call sign is K83HCO, and I will be your ARIS moderator for today's ISS contact with the Namibia Scientific Society in Windhoek, Namibia. Through the help of amateur radio volunteers and the crew on the ISS, we soon hope to establish a radio contact with the International Space Station as it flies more than 400 kilometers above the Earth over Artselar, Belgium. This is all accomplished through ARIS. ARIS stands for Amateur Radio on the International Space Station. The ISS is currently approaching today's ARIS ground station, traveling along at 27,600 kilometers per hour. The contact for today will be performed using the ARIS Telebridge network, a worldwide network of amateur radio ground stations that enable students to contact the ISS. For those that don't know, ARIS is an international consortium of volunteers from several nations that assist to develop and operate the amateur radio equipment on board the International Space Station. Some of the agencies that support ARIS are the American Radio Relay League, the Worldwide AMSAT or Radio Amateur Satellite Corporations, and then the space agencies, the Canadian Space Agency, the European Space Agency, the Japanese Space Agency, Roscosmos in Russia, and NASA. So we are a nonprofit organization that makes this happen. Our link up today will be with the participants at the Namibia Scientific Society in Windhoek, Namibia. Now let's check in with the group. We've asked Zandre Duvenhaga to please tell us about those participating in today's contact. Over to you, Zandre. Thank you, Zandre. So now we're going to take a look at a video presentation produced by the American Radio Relay League, which shows students what to expect during our upcoming contact with the ISS.
Hi, my name is Ruth.
And my name is Chris.
You must be pretty excited to talk directly with astronauts on the International Space Station today. While we're waiting for the space station to come over your portion of the sky, let's talk a little bit about how it's going to happen. Of course, Mission Control is in contact with astronauts all the time, using a big radio with lots of fancy equipment.
However, we're going to be using something very different today. We are going to use ham or amateur radio to talk directly to the International Space Station.
When most people hear the word radio, they think of a music radio station, but it's so much more than that. Radio actually refers to the unseen energy that transmits all sorts of signals using electromagnetic waves. At first, people learned how to send signals like Morse code. And then they discovered that you can send so much more, like data, computer signals, and even TV.
Maybe you don't realize it, but you use radio every day. Maybe you watched the TV this morning, or you texted your friends, or maybe even you check social media like Twitter or Instagram.
Let's travel back to space for a minute. Since the beginning of the space age, humans have sent many spacecraft out into the universe. These range from the Hubble Space Telescope orbiting the Earth daily, and the Curiosity rover exploring Mars. We've even sent a long-distance messenger, the Voyager 1, who has traveled outside of our solar system.
Whether it's capturing a great picture of a far-off galaxy or conducting experiments on the space station, radio has to do with all of these. And today, you're going to be using ham radio. Now you might be wondering, what exactly is ham radio?
Amateur or ham radio is a service and a hobby where operators can talk with people around their neighborhoods, their cities, their country, and even around the world. Amateur radio operators require a radio license from the government. They're not that hard to get. I have one. My call sign is KM4LAO.
And mine is KD8YVJ. Our call signs are a way of identifying who we are to other operators. This lets everyone know that we have the proper license to using the radios.
As amateur radio operators, or hams as we are often called, we can talk with others about basically whatever we want, often science or some new radio gadget that we are interested in.
Let's focus back to the space station and your contact today. Many of the astronauts and cosmonauts aboard the space station are licensed ham radio operators. That's why your operators today can contact them. The people here, as well as the astronauts, are licensed to talk to each other, and you are allowed to talk over to their radio.
For our conversation today, we'll need an amateur radio station on the ground, either in this location or somewhere else around the world. We'll also need a radio in the space station.
NA1SS, NA1SS.
You can hear the calls coming. This is November Alpha 1 Sierra Sierra, the International Space Station, over.
On the space station, the radio transceiver is connected to an amateur radio antenna mounted on the outside. One of these antennas will be used today during our contact.
For our side of the contact, we need a good-sized antenna, a signal amplifier, something to make our signal stronger, and a rotator for turning our antenna. We have to keep our antenna pointed right at the International Space Station. And remember, it's moving across the sky and fast.
To aim the antenna properly, we need to track the path of the space station exactly. NASA uses complex systems to track the path of the space station and other orbiting objects.
The satellite tracking program we are using works out a complicated set of mathematics to provide the orbital location of the space station moment by moment as it moves through space. This information is sent into the computer that controls the antenna rotator, which moves the antenna to follow the space station. Maybe some of you have seen or worked with robotics. That's pretty cool stuff. And just like you can program a robot where to go, what to do, and how to get there, you can also program a computer to tell an antenna how to track the space station across the sky.
You know, it took a lot of planning to get this contact. Several weeks ago, the ISS operations team had to figure out when the space station's orbit would pass over this location. Then, they had to talk with the planners at NASA's Johnson Space Center. The crew's time is pretty full, so they were able to find a time that could work for the crew members' schedules. Once they found times that would work both in space and here on the ground, the host organized this contact. And in just a few minutes, you'll be hearing and talking to the astronauts.
Well, it's almost time for your contact. It will be exciting, so good luck with it.
Okay. So at this point, we're now going to take a look at a short video that shows how an IRIS contact looks from the perspective of an onboard astronaut. In this case, astronaut Tim Peake.
NA1SS, this is N2SJ, over. NA2SJ from NA1SS for scheduled contact.
Hi everyone, I'm Tim Peake and welcome aboard the International Space Station, where we're orbiting Earth 16 times every day. One of the most rewarding activities that some astronauts undertake on orbit is to talk to schools using the space station's ham radio. Now, these are events that are planned by ARIS, which is a worldwide group of amateur radio volunteers who are dedicated to introducing young people and students to science, technology, engineering and mathematics. Now, this is the equipment here in the Columbus laboratory, which consists of a handheld radio, a headset, and we also have a ham video unit. Now, as the International Space Station orbits above your location, a radio link is established between the ISS and your school. Now, because we're traveling at nearly 18,000 miles per hour, which is an incredible 25 times the speed of sound, we usually get about 9 or 10 minutes of good radio contact before losing the signal. So about 5 minutes before the scheduled start time of the contact, I come into the Columbus laboratory and configure the radio so that I'm on the correct channel. And sometimes I'll set up the ham video too. Just before the predicted time, I'll begin to start calling the school using the standard amateur radio calling techniques. For example, if the call sign of your school was GB4 Fun, I would say Golf Bravo 4, Foxtrot Uniform November. This is Golf Bravo 1 Sierra Sierra, listening and standing by. Now at your school, the radio operator will be listening for my call, but may also transmit and try to call me as well. You'll probably have a much more powerful transmitter on the ground than we have up here on board, so I'm likely to hear you before you hear me. Then, once we can hear each other, then comes the best bit, which is actually talking to the students and answering the questions. Once I've answered all the questions, we use the remaining time to say goodbye to each other and end the connection. I'll then spend a few minutes configuring the radio back into a rebroadcast mode, and then I'll go back to my day job, which is of course doing science on board the International Space Station. ARIS is a brilliant opportunity for astronauts to talk to school pupils. It's really rewarding to hear how excited the students are when they're talking to somebody up here in space. And it's a true privilege to be able to inspire our next generation of scientists and engineers through amateur radio.
I want to thank Tim Peake for that nice video. Now that you've seen what the contact looks like from the ground side and what it looks like on board ISS, now comes the most exciting part, your contact with astronaut Mike Fink on ISS. So as I just mentioned, our contact today is with Mike Fink, and his call sign, his amateur radio call sign is Kilo Echo 5 Alpha India Tango, KE5AIT. He'll be using the amateur radio call sign on space station Oscar Romeo 4 India Sierra Sierra, or OR4 ISS. The amateur radio ground station that will establish contact with the ISS today is ARIS Ground Station 014 ISS, located at Atzelaar, Belgium, and operated by Jan Populair's ON7UX. Jan, before the contact starts, please tell us a bit about your ground station and how you'll handle today's contact with the ISS.
Okay, thank you for the opportunity to present my ground station. The amateur radio ground station that assists you today with the radio link to the International Space Station is located in Belgium, situated in the southern region near Antwerp in the town of Atzelaar. The amateur radio ground station is kept operational by the UBA section AAA, the Antwerp Active Amateurs. And in the realization of this Irish Telebridge radio ground station are 6 volunteers directly involved. We use two-way radios, fully computer controlled for frequency control. Antenna tracking both in elevation as in azimuth is also computer controlled. Our antennas are already pointed in direction of approach, and the frequency is set in the receiving channel. So we expect to make contact with the International Space Station when it is above the Azores, and the following the ISS during 11 minutes. We have a high elevation of 83 degrees, so we probably lose contact when the ISS is going away over Eastern Europe. So I do have a noise checking. That give you an expression when I start calling the International Space Station with the call sign Oscar Romeo 4 India Sierra Sierra. I listen to the response, and when I hear noise, that means that there is no answer, that he probably been under the horizon for me, my station, so I have to wait when they pop over the horizon. And when I make when the communication is established, I ask astronaut Mike Fink if he is ready. And so I pass the communication to you with the words, and Zandre, go ahead. And that's the sign for the school for the asking questions. That's all what I have to say, Frank, for the moment.
Okay, thank you, Jan. We are now about 2 minutes before the planned acquisition of signal from the ISS. I didn't mention this, but I'm in the United States. I live in Maryland, a town called Towson, Maryland, north of Baltimore. And at this point, with the time of the ISS contact quickly approaching, we want to remind everyone to please mute your cell phones and be as quiet as possible when not asking Mike Fink a question. And of course, the students need to be loud and clear as they ask the questions. An important thing to remember is that what we are doing on ISS with this ARIS activity is an experiment. So we can never tell the results, positive or negative, until the experiment is over. And questioners, don't forget to say over at the end of your question. The International Space Station is coming very close to Jan's radio station in Belgium. So I'm going to turn it over to Jan. It's all yours. Good luck, everybody. Over.
Okay, that's important. When I change from receiving to transmit, the sign for me to switch is the word over. So finally, when you ask your question, close your question with the word over. That's important. I have an elevation from -1.2 degrees. So I expect to make contact in a few seconds, and I open the channel for listening. So I start calling for the International Space Station. Here is Oscar November 4, India Sierra Sierra, for an ARIS scheduled contact. Oscar Romeo 4, ISS. How do you read me? Over. Roger, Roger. I hear you in the noise, Mike. I hear you in the noise. So your signal is being received, but your transmission will be better than your next. Over.
Good morning. Yes, we're only getting better, and I'm ready for the event when you are. This is the International Space Station Oscar Romeo 4 ISS.
Okay, thank you, Mike, for your response. You're a little bit in the noise, but we have students from Namibia Science Society in Windhoek, Namibia. So, Zandre, your school, go ahead, over.
A bunch of learners that are ready to speak to you, so I'm going to hand over to the first one.
Hi, this is Mike's son. Would you recommend your current occupation to another individual? Over.
Guten Morgen, good morning, and bonjour, and welcome to the International Space Station. Mike speaking, and yes, I would recommend my current occupation to another individual because it makes me happy, but I suggest that everybody finds a occupation that satisfies them. Over.
Yeah. That was the first question, but we didn't hear the audio. Please repeat.
Just what form of communication does one use in space? Is there internet in space? Over.
Yes, this is a good question. We have different ways to communicate. We have several types of radios, including high-speed radios that allow us to communicate with satellites and back to the Earth. And yes, we do have internet. Our Wi-Fi is not too bad, and sometimes we can send email. Over.
Hi, this is Trevor. If light takes millions of years to reach us from distant galaxies, could some of those galaxies already be gone by the time we see them? Over.
Yes, that's how the speed of light is the fastest thing we know, and yet sometimes it seems slow. Yes, those galaxies could be gone. We would not know until later, but likely they are still there. Over.
Yeah, Suzanne, please repeat. We have no audio.
Hi, my name is Suen. If you could take one thing from Earth into space that makes you feel ill, what would it be? Over.
Yes, we're gone away from our family, so having a picture of my family makes me feel at home. I miss them very much. Over.
Travel in space. Over.
Yeah, we have no audio. Please repeat.
Emily, how do you overcome the challenge of missing home and family as you travel in space? Over.
Good to hear you in space. I miss my family very much, so we have a video conference once a week, and I can talk to all of my children and to my wife. Over.
Hi, my name is Aaron. What life support systems help astronauts survive in space? Over.
Have our oxygen and to breathe in, and when we breathe out carbon dioxide, so that gets taken out of the air. So that is some of the important thing for our life support system. Over.
Black hole and white hole. Could there also be something like a green hole? Over.
Yes, that's an interesting logical question, but unfortunately, as far as we know, there's only kind of black holes, white holes maybe, and we need people like you to help understand the universe better. Over.
My name is David. What impacts does the launch, landing, and the stay in the space station have on the human body? Over.
For us, launch and landing aren't too bad, but it's the long time in space that can hurt us, that can make our muscles and bones deteriorate, so we have to exercise at least 2 hours every day. Over.
How does a massive star dying create a black hole so powerful that time slows down and bends its light? Why do we only ever see its effects and not the black hole itself? Over.
Yes, black holes are so powerful that light cannot escape. But is a thing called accretion disk, which generates a lot of light. So we can see the black hole indirectly, and these are great questions for people, young people like you, to discover more about our universe. It'll make life better, planet Earth. Over.
And what types of food and beverages do you consume while aboard the spacecraft? Over.
Yes, because to bring up 1 kilogram of space to the space station costs somewhere around 5,000 euros, and it's very expensive. So we have water up here. We make our own water. We recycle water, so it's a lot more inexpensive to send dehydrated foods, and they last longer. Over.
Hi, my name is Muduba. What could happen if something falls into a black hole? Over.
Hello, Muduva. Hello from space. If something fell into a black hole, it will start to what we call spaghettification. It will look like it again. Over.
This is Mike, sir. How is life in space? Over.
Life in space is amazing. I love it. I've been here for over 400 days, not in a row, but over 4 missions. I enjoy looking at planet Earth and flying. Over.
Over.
Yeah, please repeat. We have no audio.
What gives you direction? Over.
I think this must be a question about how to land on the moon. We have great maps on the moon, and we use a lot of cameras and optical recognition based on craters and landmarks to find where to land on the moon. In the future, we will have like a moon GPS. Over.
Yeah, please repeat. We have no audio.
My question is, why do most galaxies seem to have supermassive black holes at their centers, and what role do these black holes play in galaxy formation? Over.
A great question. Some galaxies have supermassive black holes, some do not. Why is that? We do not know, but we are studying them, and we have big telescopes in space, and we need all the help we can get to figure these cosmological problems out. Over.
What is the most to the most in space? Over.
Yes, the most surprising thing I had to learn on Earth was how to learn quickly, how to learn new things fast. And for example, I learned Russian language, and that helps us most in space. Over.
Just space movement. Over.
Yes, robots and artificial intelligence along with humans will play a big part of our future. They will help us to be safe as humans and to explore, but we can't do it without the human mind and the human creativity. Over.
What space experiments are you working on about the International Space Station? Over.
Okay. Thank you, Mike. I think we have lots of signal. This is give the school in Namibia the chance to thank you.
Mike, from our side, thank you so much for being part of this event. Safe travels in space. Over.
This is International Space Station, 0 Oscar Romeo 4 ISS. Over.
Okay, thank you for the good contact, Mike. We see you once again in Kennedy Space Station when you remember me. Okay, 7-3.
Okay. Thank you, Jan. Oh wow, what an experience, ladies and gentlemen. We've just shared a moment of history. Image Radio Ground Station ON4 ISS, located in Artelaar, Belgium, and operated by Jan Populiers. ON7UX contacted Mike Fink on board the International Space Station. I got to talk to all of you students, as well as everyone in the audience in Windhoek, Namibia. So Now for the International Volunteer of ARIS, including the amateur radio satellite corporations around the world, American Radio, the American Radio Relay League, the space agencies, Canadian Space Agency, European Space Agency, Japanese Space Agency, Roscosmos in Russia, and the National Aeronautics and Space Administration in the United States. This is Frank Bauer, KA3HDO, your ARIS moderator, sending my salutation to each one of you in amateur radio terms. Our salutation is 73s, which means best wishes. Back over to the Sandre and the group in Namibia.
So, I think we can all express our gratitude and our excitement that that was successful. We had a few challenges, but it all worked out. So let's give them another round of applause. I think what we can maybe do is just while we still have everyone here, while we're in excitement, can we get all 11 learners to come stand here in front of the World Space Week banner? And then we just let one of our photographers take a picture for us, a group picture. Awesome.
Okay, Jan, I think we are done for today, okay?
Okay.
And I've been given, well, thank you very much for the outstanding work. Bit of a challenge there, but every one of them, we got, what, 17 questions answered? Is that right?
Yeah, like that.
Yeah.
I need to count it. I was busy.
I know you were busy. Yeah, the last one we did was the time.
So maybe while we're on a point of thanks, I think you guys can appreciate that there's a lot of technical things that can go wrong on a day like this. And so what we did is we asked the people that we know that does these technical things the best, RB Media, Reinhard there sitting there at the back, and his team here with the caps and the photographer. So they came and they supported this event free of charge. So let's give them a massive round of applause as well. Their logo is right here. They also helped us to stream this event live. So while you guys are sitting in the audience, the rest of Namibia had the opportunity to watch this live. And I'll be also on our YouTube channel or the Namibia Scientific Society afterwards. So you can go watch it and share it with your family and with the school. That's awesome. Thank you, Ryan, and the team. So we still have a bit of a program. Guys, if you can just, I know it's exciting, but we don't have to be that quiet anymore, but let's still remain focused. We're going to still be here for about 30 minutes. We have to wait until the school traffic has gone away before we can start moving out to our buses. So our official program will be at 1:30. But to tell you a bit more of the technology that we actually use with these types of radio connections, we actually have radio specialists right here in the country. That's called the Namibian Amateur Radio League. Did you know that they can build a radio with the things you find in your kitchen? Well, to tell us more about what they do, they don't just buy radios and use it. They can actually build radios themselves. We have Robert here that's going to tell us a bit more of the technology that was used to speak to the astronaut. Let's give Robert a hand as he comes up. There you go, Robert, all yours.
Okay, thank you, Andre. And I hope you guys had a nice view there.
Guys, can we just remain still a bit silent so that we can hear the speaker speak? Can we give him that respect, please? Thumbs up from everyone. There we go. Thank you.
Okay, thank you very much. My code sign is Victor 51 Romeo 0. And yeah, I'll quickly tell you why Victor 5. I think you guys noted already on aeroplanes, Namibian aeroplanes, they have a Victor 5 on it and then the code sign. And the Namibian ships, the same, Victor 5 and the name or the code signs whatsoever. And like I said, we use radio images to communicate. I mean, you guys heard today a lot of choices, what you can do, and yeah, hobbies and all that stuff. And like I said, we do the communication with the radios. I saw on that picture, strange to see myself thing, they use the same radio here. And with that little radio, what I have here in hand, we can build yourself, you can build an antenna and speak with this radio over the whole world. And yeah, do some communication. And yes, we may as well talk to the astronauts itself. We have, because they are radio amateurs and we are as well. You must get the little course and or make it so, and then you can be a radio amateur. What are we using the radio communication as well in disasters? And all the countries where the cell phones or the electricity went down, the radio amateurs can build their own radios or use their own equipment, a solar panel, a battery, antenna, and get help from other side of the world or the next country or in the country itself. We, in our country, I mean, you guys know how big our country is, from the Etoshapan to Swakop or the whole side. We can use a little hand radio like this one, and we can talk via the repeaters or repeater systems, and yeah, have fun and talk or get really business if there is a problem. Yeah, that's actually from my side. We have the website. You can Google. That's a Namibian Amateur Radio League, and yeah, If you Google, you will find us, and you can come in contact with us. And yeah, you can build your own radio or little electrical gadgets, what you want to do. That's all from my side. Yeah, I don't know if there are some questions.
What does it take one to become an amateur radio operator?
How to become a radio amateur? First of all, you, if you love play with radios or electronic devices, you can check on our website. You contact us, and yeah, you can write the exam, and then you can start with your radio.
Is there an age limit for you to go into space?
With the space, I haven't got too much to do, but we can talk to them. Yeah, with the space, we yeah, yeah, the permission you must get from your parents to go there to space.